Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Question 3, showing here two tall buildings. As we said many times earlier in paper 1 and paper 2, to obtain or to get clear echo, the reflectors or the barriers we have here, they should be large, flat, smooth. Okay, this is number 1. The second point here, you have to identify that here you have two buildings, so reflection takes place at building A and at building B. Where is the sound source? Here the student stands at P. He is clapping his hands, so here we have the sound source. So the sound source is here. Okay? Calculate the time interval between clapping his hands and hearing the first echo. Let's draw in different colors how sound will travel. The first echo, it will take place at the building which is nearer to the person. So he will hear the sound source is here. It will travel in this direction and it will be reflected back to the student. So the first echo here, if you would like to calculate the time interval, so time is equal to 2 times the distance, which is 33 meters, and the speed is mentioned, the speed of sound in air, 330. So the answer is 0.2 seconds. Is it clear? So this one is simple. You will write here 0.2 seconds. The second part, calculate the time interval between clapping his hands and hearing the third echo. Okay, the third echo, here we have the sound source, but it will be reflected twice. The sound source will travel in this direction and it will be reflected back to the second building and back to the person. So reflection takes place here 2 times. If you calculate the total distance traveled, you have here 33 meters, you have here 99 meters, you have here 66 meters, because here this dimension is 99 minus 33, which is 66 meters. Okay, so the total distance traveled to hear the third echo, it will be time interval is equal to distance divided by speed of sound. So the total distance as shown is 33 plus 99 plus 66 divided by 330, which is 198 divided by 330. So the answer will be approximately 0.60 seconds. Write down an approximate value for the speed of sound in water and in steel. You know that speed of sound in solids is faster than speed of sound in liquids. Speed of sound in liquids is faster than the speed of sound in gas, and so on. You can estimate the speed of sound in water 1500 meter per second. In steel it's almost 5000 meter per second. Okay, the last part showing a dolphin in water emitting sound waves of frequency 95 kilohertz using your value from CI. So the speed of sound in water you mentioned here, you will use it to find the wavelength of sound waves. According to wave equation, if you rearrange, you have to substitute here your value using your value, which is 1500 meter per second, but check that the frequency here you should have consistent units. So to convert kilohertz to hertz, you know that prefix kilo means is equivalent to 1000, which is 10 to the power of 3. So you have to write here 95 times 10 to the power of 3, so you can find hertz. When you substitute and get your final answer will be 0.0157 meters.
Subscribe for more videos. I love physics splendor. I love physics splendor. I love physics splendor. I love physics splendor.